This video is the first installment in adding, subtracting rational expressions. This video is going to deal with denominators that are monomials. We'll have some like ones, some unlike ones, and in subsequent videos we'll have some binomials that are like and unlike also. So rational expression is a fraction the reason why it's a fraction is because of the word ratio in the word rational. That means fraction, and it's a fraction with variables. Okay, usually they're in the denominator, but they can be in the numerator. It really doesn't matter. They could be in both. They can be different variables. It doesn't necessarily matter. So in this particular instance, I want to add and subtract rational expressions, or just fractions with variables, and I need to remember how to add and subtract fractions. So when I add and subtract fractions, I need the same denominator. Okay, so needing same denominator is really easy when you have, again, same denominators. Remember, my denominator hopefully is my bottom number of my fraction. Because those are both the same, I can just add or subtract now. So a couple things before that. One is, remember, this is what we call a binomial. This is a binomial. This is a monomial. And same thing here, this is a monomial. So they need to be, my denominators need to be the same nomial. They can be, polynomials, trinomials, binomials, doesn't really matter, but they got to be the exact same in order to add or subtract fractions. Because my denominator is the same in both fractions, my denominator at the end is going to be 25v squared. Now, up top, what happens? My u minus 7v is going to stay there. Okay, that's going to remain there. It doesn't change. But then I have a negative in front of my second fraction. That negative acts as the distributive property and distributes through that binomial. So it's now a minus u minus a 2v. So now up top I combine like terms. U minus u is gone. I don't have any left. Negative 7v minus 2v is negative 9v over 25v squared. So this looks to be my answer because I now added and subtracted, right? I really just subtracted them. But if we recall from a previous section where I have to simplify algebraic fractions or rational fractions, rational expressions, then I have a v up top, I have two v's in the bottom, so that means really I have one left in the bottom of my fraction. So my answer is negative 9 over 25v. This is my final answer. This is not. Okay, so final answer, negative 9 over 25v. Let's look at this particular problem. Okay, if I look at it again, my fractions, my denominators are exactly the same. Remember, they are monomials. Okay, it's only one term. This is a binomial up here and a binomial up there. So because I have the same denominator, I can rewrite my answer with my denominator there. Okay, now up top, what do I have? Well, I have x minus 2y. This is a plus 1 that gets distributed, so when I add, it really doesn't change. So plus x plus 2y over that 28x squared y. Now I can combine like terms in my numerator. X plus x is 2x. Negative 2y plus 2y is 0, so these are canceled, over my 28x squared y. Again, from the previous problem, I can reduce because they're both monomials. So I have a 2 up top and a 28 below. So that 28 actually turns into a 14, and the 2 turns into a 1. I just divided them by 2. Now if I look at my x up top and my x squared in the bottom, my x up top is going to go away, and my x squared in the denominator just brings it down 1 degree, because when I subtract again, I just get 1 left. So my answer is what's left up top, 1, over what's left on the bottom, 14x, only one of them, and then the letter y. I didn't do anything with it because my y's up top canceled. So this is my final answer for this particular problem. Go ahead and pause the video and try this particular problem, and then I'll go over the answer once you hit play. All right. Again, my denominator is 24nm. It could be mn, it doesn't matter. Again, it's multiplication, it's commutative, so I can change the order and things. Up top, because I'm adding, I get m minus 7n plus m minus 7n. okay, because it's a plus, nothing changes when I distribute. So now combined like terms up top, I get 2m, because m plus m, minus 14n, because negative 7 minus 7, over 24nm. Now, some of you are like, oh, that's my answer, and some of you might have had that, and others probably went further. You need to go further because that's not fully simplified. So if I look at my numerator of my fraction, both my numbers, the 2 and the 14, are divisible by 2. So that means I can pull out a 2. Times what is left to get what I started with, m minus 7n. If I redistribute the 2 through, I get what I started with up here, and that's the whole goal, right? Factoring is what we call undistributing. Okay, so that's what I'm doing. I'm factoring, all right? Undistributing. Divided by still my 24nm. Now, I'm just going to rewrite it over here to the right here just so I can look at it without different colors in there. Now, if I look, this 2 is a monomial. This m minus 7n is a binomial, and then this 24nm is a monomial. Remember, when we cancel rational expressions, I can only cancel like nomials. So 2 and 24, because those are both monomials, I can cancel. So this becomes a 1, and this 24 becomes a 12. So what am I left with up top? I'm left with an m minus 7n, with the 1 out front, but I just distributed it and it goes away, over 12nm. Again, now some of you are like, well, I have m's up top and n's up top. Why can't I cancel with the nm's in the bottom? They're not the same nomials. I cannot get rid of different nomials. So that is my answer for this particular problem. That concludes this video. We'll do separate videos. This video is only for adding, subtracting rational fractions, rational expressions with like denominators. We'll go, if you need help with unlike denominators, please watch the next one.